Okay, so now we're going to start 7.2b, which you'll notice is our quotient of powers. We have a very similar lesson objective as we did last time. However, this time it wants us to be able to divide powers still with that same base. So similar to what we did when we were multiplying our exponents, or multiplying our powers, excuse me, we're going to use that expanded form that we learned back in the previous unit to prove that division rule of exponents, prove that it works. All right, so first thing we're going to do is we're going to write this expression, which is 7 to the 5th over 7 to the 3rd in expanded form. We know that this over actually means to divide. So what we're doing is we're doing 7 to the 5th power divided by 7 to the 3rd power. So similar to what I did in the last lesson, I'm going to take each one separately. I'm going to first just focus on that top power. So that top power tells me it's 7 to the 5th power, which means I'm multiplying the base by itself. That's 7 by itself 5 times. That's how many times the exponent is telling me. So I'm literally going to just focus on that and write that out in expanded form. And I think I'm going to do it over here to the side so I have some more room. All right, so I have 7 times 7 times 7 times 7 times 7. So I've multiplied 7 by itself 5 times, which is what I needed to do for that top, that numerator, that power that's in the numerator. So now all of that's going to be over or divided by 7 to the 3rd power, which again, that tells me I need to take that base of 7 and multiply it by itself 3 times. So 7 times 7 times 7. So now I have my 7 to the 5th power divided by my 7 to the 3rd power. I've put these in expanded form. Well, you might start to notice and look at something that I might be able to, when we get to the second step, it wants us to go ahead and put it in the form, in exponential form with that single exponent. So right now we don't have a single exponent. We need to get there. So I notice that if I have a 7 divided by a 7, I get the value of 1. So these more or less just cancel each other out. Well, then I notice I have another one that just cancels each other out because 7 divided by 7 is 1. And then I see that I have another one, which is 7 divided by 7, which will get me 1. So if I wanted to go ahead and write this in as a single exponent, I obviously still have that same base of 7, so I see that I have 7. But now when I go and look, I see I actually have 7 being multiplied by itself twice. So I have 7 to the 2nd power. So using that expand form, which led me to getting an exponential form with that single exponent, my next step, my final step is, if possible, to go ahead and evaluate. Well, we can evaluate 7 squared. That's one of the ones we had to memorize. So 7 times 7, or 7 squared, gets us that final answer of 49. So we were able to go ahead and solve that. So similarly, I love that word, we can try to find a pattern or try to notice an easier, quicker way to be able to go from 7 to the 5th over 7 to the 3rd to that 7 to the 2nd to that final answer, that answer in standard form of 49. Start to look for those patterns. What do we see? What could we have possibly done looking at those exponents while we're dividing powers to get it to a single exponent? So in fact, in order to, we'll go down to my actual division rule down here. In order to divide, which is what we were doing today, that fraction bar means to divide two expressions that have to have the same base. That is very important. They must have the same base. What did you see that we did with our exponents? We subtracted the exponents. Okay, so if we have the same base and we're trying to divide two powers with that same base, then we can go ahead and subtract those exponents. And you can see I kind of set up a formula here where I have a to the m power divided by or over a to n power, and that's the same as doing a to whatever m was minus n. Notice that it's the numerator subtracting the denominator. Don't go in the opposite direction. It's the numerator that subtracts the denominator, okay, top to bottom. Similar to reading left to right, we also read from the top to the bottom. All right, so let's look at some examples. So we're going to write each expression using a single exponent first. Same thing that we had done before. Oops, sorry guys. Same thing that we had done before when we were multiplying our powers. This time we're dividing them, so we're going to put them into a single exponent, and then if possible, we're going to go ahead and evaluate. So I go and I look at my very first problem, and I see that I have the same base of m. And I'm dividing that same base of m. So what I know then is my base of m gets to stay the same. But then I need to go and I need to look at my exponent. So I see I have a 12 in the numerator and a 5 in the denominator. So I'm going to do 12 minus 5. Well, I know that I can simplify that. So now I have m, and when we go ahead and we do 12 minus 5, we end up with that answer of 7. So my final answer becomes m to the 7th power. So let's look at my next example. All right, so I see that I'm doing division. I look to see if I have the same base. I see that I do have the same base of -1. So I want to keep it in those parentheses because it's -1 times itself, not times itself and the opposite of that. So then see I've got that 5 on the numerator minus the 4 on the denominator that's attached to the base and the denominator. So then I go and I solve, and I've got -1. 5 minus 4 is to the first power. So -1 to the first power is just going to be -1. So there's my final answer. All right, next one. All right, so if you remember when we did our last unit, when we did 7.2a, one of the things that we talked about is we did that numbers, numbers, letters, letters. So what we're going to look at is this one is very similar in that I'm going to focus on those coefficients in my numbers, and then I'm going to focus on my letters, my variables, and see what's happening when I'm dividing those with those exponents. So initially, I'm just going to ignore the fact that I've got some coefficients. I'm going to ignore the fact that I have any variables attached to this problem. So I'm going to look and see, is there anything that will go into both 12 and 2 in order to simplify this problem? So I could actually divide both by 2, which would be awesome. So 12 divided by 2 gets me 6, and then I see that 2 divided by 2 is just going to get me 1, so I'm not going to worry about it. So now I get to go ahead and look at my variables. Numbers, numbers, letters, letters. So I look at my variables and I see that I have that same base of 6. And I see I have a variable of 9 in my numerator and a variable of 6 in my denominator. So my base stays as the same as that x, but then I get to do 9 minus 6, which we know is going to be 3. So my final answer becomes 6x to the 3rd. And I'm done. I've simplified it as far as I can go. I do not know what x is, so I can't do any more evaluating at this time. But I've made the problem a lot easier too. Next one. So this is x divided by x to the 3rd. So I see I'm doing some division, which is great. I see that I have that same base of that x, which is also great, but I'm noticing something that I need to put with that x that's in the numerator. And we had a similar problem like this when we were working on our multiplying or our product of powers. We needed to make sure that even if you have a number or a variable that is on by itself and it doesn't seem to have an exponent, it really does, it has that exponent of 1. So I need to make sure that I put that in so I don't forget that there is an exponent there. So I noticed that based on my rules that I learned before, I need to take the numerator and subtract the denominator. So I have 1 minus 3. So when I go ahead and I start to solve that, I see that I have x negative 2. Well, we also learned in 7.1 that we cannot have negative exponents. It's not acceptable. So we remember, if you remember back from what we did before, a different colored pen here. We would have to, our first step was to always put our exponent over 1. We wanted to get it into a fraction. If it wasn't already in a fraction, we wanted to turn it into a fraction. And then we asked ourselves, is this a happy variable? Is this one a happy power or a sad power? Well, we realized that it's sad power. So then we asked ourselves, does it get to stay or does it have to move? When we know because it is sad, it actually has to move. So it's in the numerator, it's on the top, so it has to move to the bottom. And when it moves to the bottom, it becomes a positive exponent, so now it's happy. So then we have to make sure we have a placeholder if we have no numbers up in the numerator, so we have to go ahead and put that 1 up in the numerator just so we know that that x to the second power x squared is in the denominator. So again, we can't evaluate any further because we do not know what x is. So our final answer is 1 divided by x to the second, or 1 over x squared. All right, second to last one. So I see here I've got another numbers, letters. I see I have some coefficients, and I also see that I have some variables. So the first thing I'm going to ask myself is I'm going to focus on those numbers. I'm going to pretend like my variables are not even there. And I see that I have a 5 and a 25. So is there anything that will go into both 5 and 25 to simplify it? Absolutely. I see right away 5 divided by 5 is going to give me 1 on the top. And I'm going to go ahead and put that for right now. And on the bottom, 25 divided by 5 is going to go ahead and it's going to give me that 5. So be careful. A lot of people just put 5 in the numerator. But it's not 25 divided by 5. It's 5 divided by 25. So we need to make sure that we have, we've simplified it in the correct order. So now I have this variable. Now I get to focus on those. So I see I have my y, which is awesome. Got that base, that same base. And then I need to focus on my exponents. And I see that I have 3 minus 10. I have to take my numerator and subtract my denominator. So I see I have 3 minus 10. So I go ahead and I start to simplify this further. See that 1 times anything is just going to be itself. So now I have y to the negative 7th over 5. Well, just like on our last problem, we said that we cannot have negative exponents, that that's not okay. So I need to look at all of my powers and determine if they're happy or they're sad and get them in order to have positive exponents. So awesome, step 1's already done for us, and that's already as a fraction, so that's wonderful. So then I look at my y to the negative 7th. It has a negative exponent, so it's sad. So that means it has to move, it cannot stay. My 5 is already down here, so I have 5y to the negative 7th, and I need, that became a positive, sorry, 5y to the 7th, and then I have a 1 on top. So I'll rewrite that since I goofed that up a little bit. Sorry about that. 1 over 5y to the 7th, because when I moved it, it became positive. That's better. I don't know why it's having trouble focusing here. All right, last one. So this one has numbers and 2 different types of variables. So this is like a numbers, letters for sure. Let me see if I can get to focus here. So first thing I'm going to do is I've got to focus on those numbers first. So I see right away that I have this negative 15. And I see that I have a negative 3. So the first thing that I want to do is I want to make sure that I focus on those. So what number will go into both negative 15 and negative 3? Yep, negative 3. So negative 15 divided by negative 3 is going to give me a 5. Negative 3 divided by negative 3 is going to give me a 1. And because it's going to be in the denominator, I don't have to write it. If you write it, it's not going to be wrong. It's just one of those unnecessary things that you don't need to do. So I'm going to focus on my first variable, which is my x. And I see that I have my x, and I'm going to focus on the exponents that were within the x, and I do the numerator minus the denominator. So 6 minus 5. And then I see that I have a y. So then this one, when I look at numerator minus the denominator, I see I have 5 minus 6. So I'm going to simplify. I have 5x minus 5 just as 1, which is awesome. And then I see that I have y, and 5 minus 6 gives me a negative 1. So I see that I have a negative exponent, which we've already learned we cannot have. So we need to go ahead and we need to get so that all of my exponents are positive. So I notice that my problem is not, my expression is not in fraction form, so I'm going to go ahead and put it in fraction form and put it over 1. Draw my fraction bar. And I'm going to look at my 5. Does my 5 have a positive exponent or a negative exponent? As a positive, so is it's happy. So does it get to stay or does it have to move? It gets to stay. And then I'm going to focus on my x with this one exponent. So is it positive or is it, is it happy or is it sad? It's happy, so does it get to stay or does it have to move? It gets to stay. So then I'm going to go ahead and look at my y, and is my y happy or is it sad? So does it get to stay or does it have to move? Yep, because it's sad, it has to move. So right now it's in the numerator, it's on the top, so it has to move to the denominator or move down to the bottom. So I have that final answer of y, 5x over y. So now notice I didn't put those exponents of 1. Again, if you did it, it wouldn't be marked wrong. You might see me write a little note next to you telling you that it wasn't necessary. But my final answer becomes 5x divided by y.